All right, guys, this is the assignment for today. Um, what I have here at the bottom is the steps you're going to take to do these problems. I'm not going over these problems necessarily, but these are the steps I want you to take. Okay, we've done them before, which is set your function equal to 0, which if you look at step number 11, it's done. Step 2, turn our polynomial into multiplication or factored form, which means you got to factor it, okay? That is not done here. This is actually in standard form, so we got to use a factoring method or multiple factoring methods to get this into factored form. Once you have it in factor form, you're going to set it equal to 0 and solve. Okay, as I do the wrap up today, you'll see a problem like this. I'll go through a problem like this. Even though we've done very similar problems like this, it's good to practice more. All right. So 11, 12, 13, 14, 15, and 16 is your responsibility today. I'm going to go over to the wrap-up section, okay, which has a little bit of everything on this. So there's 4 problems, and we're going to go through these now. All right. So problem number 1, all we have to do is factor. And like I mentioned many times before, these are your options to factor. You can use more than one. Okay, we got GCF, diamond, snowflake. Okay, remember GCF, you always want to try that. Is there a number I can factor between these two guys? So the way I've taught it is look at the numbers first, list the number, the smallest number, list all the numbers that could divide it. So number 2 is the smallest number. The smallest, or the numbers that could divide number 2 is 1 and 2. So now check, looking at this list, start with the biggest number. Can 2 divide 32? And the answer is yes. So 2 is my GCF. Again, if you're not comfortable with doing this stuff in your head, use a calculator. So my GCF for number 1 so far is 2. Okay? But we're not done, because GCF, we also could have variables. So look at each term. So this is term 1, this is term 2. Does each term have the same letter next to it? And the answer here is yes. So we have an X and an X. Everything has an X. Therefore, my GCF is going to have an X. But before we put the X down, we have to ask ourselves, what's the lowest power? Of all the X's, what's the lowest power? And that power is a single X here. So that is my GCF. So you always pick the lowest powered variable as your GCF. Once you have your GCF, we are then going to do the GCF process. I'm going to divide these guys by my GCF. All right, and now I'm going to divide. 2 divided by 2 is really just 1. Okay, you can put the 1 in if you like. You don't have to. X to the third, divide out an X, we're left with 2 X's. So it's really 1x squared, or just x squared. 32 divided by 2, or negative 32 divided by 2, that's negative 16. And then the x's, we have 1x here. I'm dividing 1 away, so there's no more x's here. They cancel. This now goes in parentheses, and we put our GCF in front. Okay, so if you think about it, we use GCF. It does not mean we're done. We have to now look at our new factors. So we have 2x is a factor, x squared minus 16 is a factor. And look, can I use one of these now? All right, and here's the hint for using these. You'll have variables to the power of 2. If you have a variable to the power of 2, that's called quadratic. That means we're probably going to use one of these. All right, which one do I use? Depends on your A value. A value here equals 1. A value here is not equal to 1. So something other than 1. All right, I also call this, when you see the x squared, we're also going to look for the ABC pattern. which I explained before, but I'm going to explain again. So if you look at our problem, the factor 2x, it doesn't have a power of 2, so I can't factor this anymore. The 2x in the front is done. But if you look inside, I do have a power of 2, which means I have to see if one of these work, okay? So to make sure they work, I want to make sure I have the ABC pattern. And the ABC pattern is this. Your A value is the number in front of the x squared. So if you look in the parentheses, the x squared has a number here. Even though it's not written down, there's an A value there. And that A value in this case is 1. So there's my A value. It's right in there. Okay, it's not written down, but it's 1. Your B value will have an X next to the number. If you look, we don't have an X next to the number, so this tells me this is my C value. Your C value is the guy without the variable. Okay, so we have our A, C, which means in the middle we're missing our B value. Okay, so when this happens and we're using this format, these factoring methods, we have to write in our B value. So I'm going to rewrite this so it's in the A, B, C format. So we have x squared. We have our C value is negative 16. We are missing the B value. When you miss the B value, you just add it in with a 0. And the B value always has a single X next to it. So now we look. We have our A, our B, and our C. Okay? So now we got to check which one of these will work. We look at our A value. Our A value here is a number in front, which is going to be 1. So we're using diamond method. All right? I know it's a lot of stuff to remember, but this is the process that, as I explained, it looks like a long time. But as you get really good at this, you will start just kind of getting it done. Okay? You'll start recognizing this. All right, so let's go ahead and do our diamond method. On top, if you remember, is A times C. On bottom is B. Okay, A times C is negative 16. Our B value is 0. What multiplies to negative 16? That adds up to 0. And that's going to be negative 4, positive 4. Okay? So once we have our magic pair, we put it in factored form. So factored form is 2 parentheses. Take your x value and split it apart because there's 2 x's, so each parentheses gets its own x. And then our magic pairs go in. Negative 4 goes here, positive 4 goes here. And do not forget, if you had a GCF, that has to go in factored form as well, in front. Okay, this is factored completely. All right. Again, for those of you who came in late, this is actually an assignment that's due today. It's the wrap-up section 1 through 4. You'll see it in the calendar. Sorry, do Thursday just to make sure. Thursday. All right. So let's do number 2. Number 2. We're using this because now we're solving. When it says to solve, these are the steps we're going to use. So first step is set everything equal to 0. If you notice, nothing is set equal to 0. So I want to make one of these sides 0. Okay, which means either I move both of these over here or move this guy over here. Okay, here's the rule. Look at your highest powered. My highest powered is x squared. If he is negative, we have to move him over to become positive. We always want the highest powered positive. So the hint says this guy needs to move over here. Okay? So if this guy moves over here, then this guy has to move over here. So our left side is going to be 0. So to move these guys, we always use addition or subtraction. So it's negative 2x squared, so we're going to add 2x squared. This cancels. We're left with 10x equals, these cannot combine, so we write them apart. With the highest power first, 2x squared minus 48. And then remember, this side now is going to be my 0, so I need to move the 10 over. It's positive 10, it turns into negative 10x. What you do to one side, do to the other. And the problem we're going to have now is 2x squared. And the next power is going to be x, so it's going to be negative 10x. Okay, and I got it from here. We can't combine this negative 10x with any of these because of the variables are not the same power. So negative 10x, and then the last guy is negative 48. And this is equal to 0. Okay? I know a lot of times we're used to the 0 over here. It's okay. It doesn't really matter. So we're just going to leave it like that. All right, step 1 is done. So after step 1, we are going to turn this into multiplication or factored form. So kind of have to do this process over here that we did. So check, do I have a GCF? Okay, so let's check. What's the biggest number that can divide 2, 10, and 48? We're going to go a little faster, but that number is 2. 2 can divide everything. That's the biggest number that can divide everything. Do they all have a variable? X, X, no X. So there is no variable GCF. Here's my GCF. I'm going to now divide my GCF. So I use GCF in this case. So let's divide out the GCF. 2, 2, 2. So what I have now is x squared minus 5x minus 24. This goes in parentheses, and I have a 2, or GCF goes multiplied in front. Okay? So now, I want to move this real quick for you so we can have a little bit of more room. Okay? So I know it got cut off. It's fine. We don't need that part. So now we still got a factor. It's not completely factored because if you look, the stuff in parentheses is actually one of these guys because I have a power of 2. That's how you recognize it. Quadratic, power of 2. Which one of these am I going to use? It's the A, B, C pattern. So it already has the A, B, C pattern. So A, B, C, we're good there. We don't have to add in the B like we did last time. And then we look at the A value in front here. Not this. This is not your A value. This is your GCF. It's the A value next to the x squared. Our A value is 1 again. Okay, so we're going to use diamond method. So let's use a diamond. Put it over here at the corner. A value, 1, times C value, negative 24. That gives me negative 24. My B value is negative 5. 1 multiplies the negative 24. That adds up to negative 5. If you know your math, that's negative 8 and 3. Use a calculator to figure those magic pairs out, okay? All right, so I have the magic pair. Let's turn it into factored form, which means I need 2 sets of parentheses. That's going to be x minus 8. Each parentheses gets an x, so we have x minus 8 and x plus 3. Don't forget your GCF in front, which is 2. All right, guys, we are done with step 2. We factored completely. It's entirely in factored form. Now we're going to go ahead and do step 3. Once you have it in factored form, you're going to set each factor equal to 0. So in essence, everything that's multiplying, I'm splitting apart. 2 gets equal to 0. X minus 8 gets equal to 0. This is what you do when you solve. X plus 3 equal to 0. And now we're going to solve for these. So the first one, since there's no x and 2 equal to 0, there's nothing to solve here. We really don't have to do that one. Okay? X minus 8, we got to add 8 to both sides to solve. X equals 8. X plus 3, we're going to subtract 3 on both sides to solve. X equals negative 3. All right, and we have solved that function, that polynomial. And here's the thing you always want to check. If it's a power of 2, you should have 2 answers, which we do. All right, number 3 is multiple choice. We want to turn this function into factored form. Basically, we are factoring here. So we have to use our method. So I'm going to write this off to the side and we're going to factor this out. So remember, we could try GCF first. So is there a number that can divide 2, 6, and 8? And that should be fairly easy for you guys here. GCF, we do have one. It's 2. 2 can divide all these. All right, it's the biggest number. Now we got to check for the variable. Do they all have the same letter? And the answer is no. So my GCF is just 2. So let's GCF out a 2. Let's factor out a 2. So we're going to divide everything by my GCF. That gives me x squared plus 3x minus 4. Bring down the GCF in front. And now, once we have this, we look at this factor. It does have a power of 2. That means we're going to use one of these guys. It does have the ABC pattern. Okay. And again, ABC pattern is this. X squared, X constant, nothing with an X, or a number without an X. Okay. So now we look at the A value. The A value is the number in front all the time. Right here in front of the X squared. Not the GCF, but the number in front of the X squared. It's 1, which means I'm using X method. So let's use X method. Our A value times our C value goes on top. So 1 times negative 4, which is negative 4. Our B value is the guy with the single X. No power here, just a single X. That's going to be 3. So what multiplies to negative 4? That adds up to 3. And you should have 4 and negative 1. Okay, and then just check that with your calculator. Multiplies to negative 4 and also adds up to positive 3. So I found my magic pair. Let's put it in factored form. It's going to be x plus 4, x minus 1, and then we have our GCF here. So let's look, which one is that? Again, the x plus 4, x minus 1, they could be switched. The x minus 1 could come first. The x plus 4 could come second. It's still correct, okay? So we guys make that clear when we look at these options. We know it's not this one, not that one. We have a 2, x plus 4, x minus 1. And there it is. So C is my answer. All right, last problem here, and we'll wrap it up. So let me move this guy out of the way. Oops. Give me a second, guys. I'm trying to move him. All right, there, he's gone. Okay, number 4. The equation m of t equals 2t to the third minus 21t to the second plus 40t represents the money in Mr. Sully's bank account over time. So t represents time, and this is measured in days. So if we put 2 in for t, that's 2 days. If we put 5, the number 5 in for t, t represents days. So that means we're measuring 5 days, okay? So real quick, let's just to make sure what we understand here. T is time, but it's in days. So if we plug something in, we're plugging it for every t, okay? Once we plug this in and do all this math, so once we solve it out after we plug in t, what our answer is going to be, and this guy don't let him confuse you. He's just our answer. Our answer, which is this guy, he'll be a number. Our answer represents money. So whatever number we get, that's how much money is in Mr. Sully's bank account after a certain amount of days have passed. So let's see what we have to do for A. Okay, so we want to find the money, M, after, what do we plug in for T? This used to be T, which represents days. So we want to find the money in the bank account after 2 days. So T is 2. I'm going to explain that. So what we're finding, so you would have to write this down, is how much money is in the bank account after 2 days. That's what this represents. Okay? So we're going to take our function. So we have 2. Instead of T, we're plugging in 2 for T to the third power. So again, I just wrote this part, but instead of T, I plugged in 2. Minus 21. Instead of T, I'm plugging in 2. Plus 40. And instead of T, I'm plugging in 2. Notice I plug in the 2 with parentheses. Very important you do that. Okay, so once we do this math, it's going to give us our answer, which is the amount of money he has in his bank account. Okay, so let's check this out. 2 to the third power. We want to do order of operations, okay? So 2 to the third power. So it's a good time to get out your calculators. 2 to the third power is not 2 times 3. It's 2 times 2 times 2. So if you throw this in your calculator, you actually get this. Okay? We're going to do the other exponent. So we got minus 21. 2 to the fourth power is 4. 2 times 2. And we'll leave this as 40 times 2. Okay? So PEMDAS says we do exponents first because there is no grouping, there's no parentheses, so we go move to exponents. Now we're going to do multiplication. Okay? So 2 times 8 is 16. Then we go negative 21 times 4. That's negative 84. Okay, and then we're going to do 40 times 2, which is positive 80. All right, now we're just going to go ahead and add and subtract this. Okay, and when you add and subtract at the end, it doesn't matter who you add and subtract first. Okay, but we'll just do it down the line. 16 minus 84. That's negative 68, and we have positive 80. So negative 68 plus 80 is going to equal 12. So Mr. Sully has $12 after 2 days in his bank account. Okay, and that's what that is saying. Last section, part B. All right, this is what it's asking in part B. When will Mr. Sully have no money? All right, so in our function, which part of the function can we put in a 0 for no money? So if you look, it's always our answer here. The answer is the amount of money. So this entire thing is going to be 0. So part B, which I'm going to do over here, instead of M parentheses T, instead of writing this down, we want to know when our answer is actually 0 money. So now we have 2 T to the third minus 21 T to the second plus 40T. Okay? And we want to know how much time will it take, how many days will Sully have no money. So guess what we're doing? We are solving. We're basically doing this process up here. Okay? We want to know what T is. Not X, but T. So we want to go ahead and factor. So we're going to GCF out. Okay, the only thing that could GCF out here, the numbers, they don't have a common factor. They can't divide. 2 cannot divide in 21. So 2 doesn't work, and we can't use 1. So the only GCF we have for part B is the letter. They all have the letter T, so I picked the lower power one, which is just T, and I'm going to divide that out. Okay, so now I have 2t squared minus 21t plus 40. And then I have t in front. Okay, now if you look, I can factor this again using, in this case, I got to use diamond because I have a power of 2, but my a value is not 1. So I have to use diamond method. All right, so what I'm gonna do, guys, I got to erase this here. I need the room. So I'm gonna erase our last problem. If you didn't copy it down, again, there's always a video of this in our Canvas, okay? So we're gonna do diamond method here. I'm sorry, snowflake method, because we have an a value that's not 1. So look at the number in front of your t squared, it's 2. So we do it the same way. What's 2 times 40, or a times c is 80. Okay. And our b value is negative 21. All right, so now, if you recall from snowflake, we're gonna put our a value here and here, okay? So this is all in previous notes. 2 goes here, 2 goes there. And then we're gonna put, each of them gets a single t, because we're splitting up the variable here. T squared gets split up into t and t. All right, so now what goes here is we have to figure out what multiplies to 80 that adds up to negative 21. Okay, so what multiplies to 80 that adds up to negative 21. So with your trusty calculator, we got the bigger number, so we have to figure this out. So we go ahead and throw this in. I'm actually trying to figure it out now. So we want what multiplies to 80 that adds up to negative 21. So it's going to be negative 16, negative 5. Cool. And when we do snowflake, we're going to reduce here. Okay. So remember, when you're doing this process, we've got to reduce, and we're going to reduce by 2. 2 can divide 2 and negative 16. So this turns into 1t. And this bottom one turns into negative 8. We cannot reduce here, so we're going to put in factor form, which is 2 parentheses. And that's going to give me t minus 8 in one of them. All right, again, I got that from here, t minus 8, and then 2t minus 5 in the other. And then I'm going to put my GCF, which was t in front. Remember, all this is equal to 0 because we want to know how much time before he has 0 money. Okay, so now we split like we did earlier, and we're going to solve. Okay, so the first one, t equals 0 is there. We have t minus 8 equal to 0. And then 2t minus 5 equals 0. So we're going to get 3 answers here. We have 1 answer. Add 8 to both sides here. Another answer, add 5. So we have 2t equal to 5, and then divide by 2. So t equals 5 over 2. So basically, there's 3 points where he will have 0 money. Okay? Only 2 of them make sense. Remember, T stands for days. So, he will have no money on 0 days, which makes sense. So, when he doesn't even have a bank account, he's going to have no money. That's what that means. Okay? So, 0 days have passed, he has no money. So, that's really not a cool answer, but it makes sense. And our next answer is after 8 days, he's going to have 0 money. And this makes a lot of sense here. It's a good answer. Over here is not so much a good answer because we can't have half days. That's what this is. We want full days. So if I had to choose a correct answer, I'd probably choose 8. All right. Cool, guys. Thank you for doing that. Let me get you the check-in code and get you out of here.